Find the electric pulse over the shaded area if the strength of electric field is 10 Newton, 10 root 2 Newton per Coulomb. The direction of electric field is shown here. This is a coordinate given. The point Q is 0, 4, 3 and this coordinate is 5, 0, 0. Then we have to find the electric flux at this surface area. We can find the area vector equal to 5 into 3 into j cap, because normal to this surface is along y cap, so 5 into 3 j cap, 15 j cap, and E vector equal to mode of E vector into E cap, or mode of E vector into PQ cap. So mode of E vector into mode of P vector into PQ cap. Now the direction of electric field and PQ is same. That is PQ cap equal to E cap. Given mode of E equal to 10 root 2 Newton per Coulomb. So PQ vector will be equals to 0 I cap plus 4 j cap plus 3 k cap minus 5 I cap plus 0 j cap plus 0 k cap equals to minus 5 I cap plus 4 j cap plus 3 cap. Hence mode of PQ will be under root minus 5 square plus 4 square plus 3 square equal to 5 root 3. So using this formula we can calculate the electric field, and so phi will be E vector dot A vector. Now so E vector will be 10 root 2 into 5 minus I cap plus 4 j cap plus 3 k cap by 5 root 2, or 2 into minus 5 I cap plus 4 j cap plus 3 k cap, or equals to minus 10 I cap plus 8 j cap plus 6 k cap Newton per Coulomb. And phi will be that is flux of electric flux E vector dot E A vector minus 10 I cap plus 8 j cap plus 6 k dot 15 j cap. Only this will remain. So minus 10 into 15. This will j cap, and other two terms will be 0. So j cap j dot j equal to 1. So 15 into 8 voltmeter, or 120 voltmeter, or Newton meter square. You can use any unit. Next, a ring of radius r is oriented horizontally, and an electric field E vector E equals to E naught r square. Where E naught is the constant and r is the distance measured from the center of ring, is directed in vertically upward direction. Find the value of electric flux over the area of the ring. From center of ring is directed vertically. Here it is shown that is a ring is placed in the plane of the paper, and E vector is perpendicular to the plane of paper, and depends the value of E vector is given by E naught into r square. That is value depends on r. Now consider a circular strip of thickness dr at a distance r from the center. Area of a strip dA vector 2 pi r into dr into n cap, where n cap is the unit vector perpendicular to the plane of ring and directed along electric field vector. So d phi E vector dot dA vector E naught into here r is given distance measured from the center of the ring, that is r is the distance in the plane of the ring. So d phi equal to E vector dot dA vector E naught into r square n cap dot 2 pi r into dr into n cap, or 2 pi E naught rq into dr. Hence total flux phi will be integration 0 to r d phi, because circle radius of circle is given capital R. So 0 to r 2 pi e naught r q into dr, 2 pi no e naught 0 to r q into dr, and integration is r4 by 4. So 2 pi e naught r4 by 4 0 to r, limit 2 pi e naught r4 by 4 or pi e naught r to the power 4 divided by 2. Answer: this is the flux, total flux from the circular area. Next question: a square loop of side length L is oriented in xy plane as shown. Find the value of the electric flux of electric field existing into the region is given as E vector equal to E naught under bracket 1 plus x by L into k cap, and E vector equal to E naught 1 plus y by L into k cap. Here situation is shown, the area is in xy plane, so its unit vector will be along z direction, and electric field is given here in vector form, so there is no need to know the it is clear from here, it is also in z direction. Now the coordinate is given, that is the length of this circular length of this square is given, that is L, and this vertices is at a comma 0, and this vertices, this point is at a plus L comma 0, and this whole distance is L. This is also L. To find the electric flux, first we take a element of thickness dx at a distance x from x-axis. So phi will be integration d phi e, integration E vector dot dA vector. So integrating from this point is this, if we take at this point, then integration will be a to a plus L. So integrating a to a plus L, E naught into 1 plus x by L into k cap dot L dx, area of this part, L into dx into a k cap. So a to L integration E naught L into dx plus a to a plus L E naught x dx, or E naught L integrating the integration of dx is x, so a to a plus L, and integration of x dx is x square by 2, so E naught into a to a plus L. Solving here, E naught L square plus E naught by 2 into a plus L square minus a square. This is the answer. For second case, because here variable is y, electric field depends on the y value, that is coordinate y coordinate, so we have to take a strip like this. So integration phi will be integration E vector dot dA vector, or E naught into 1 plus y by L into k cap dot L dy into k cap, or 0 to L, and this difference, this limit will be 0 to L. So 0 to L E naught into 1 plus 1 by L y by L into L dy, where L dy is the area, or E naught 0 to L E naught into L dy plus 0 to L E naught y dy, E naught into L integration of dy is y 0 to L, and E naught integration of y dy is a square by 2 0 to L. Putting all value, E naught into L square plus E naught by 2 L square equals to 3 E naught L square by 2. Answer. So flux will be this value. A charge Q is kept at the center of a cylinder of radius r and height 2h. Find 1. The value of electric flux over the upper cross sectional area. 2. The value of electric lines of force passing the lateral surface. here it is shown the charge is placed at this point. So electric field will be like this in, and in electric field due to this charge is radially at every point. So we can, for to find the electric flux this surface or this surface, we have to consider a circular strip, and then find the flux of this circular strip, and then integrate it from 0 to r, that is radius of that circle. So phi, here it is shown here the radius of this cylinder is given r, circular part is r, and we have taken a circular strip at a distance r from the center. So, and if this is angle theta and this distance is r, then and it is from the center of the if whole distance is 2h, then from center of the cylinder this distance will be h. Here it is shown h. So this distance will be root under h square plus r square from the plus q charge. So flux will be integration d phi integration e vector dot d vector, or integration of e dA cos theta. Now integrating 0 to r1 by 4 pi epsilon naught, and q by under root h square plus r square to the whole square into 2 pi r dr, and into cos theta equals to h by under root h square plus r square. So q into 2 pi h by 4 pi epsilon naught 0 to r dr by h square plus r square to the 3 by 2, or qh by 2 epsilon naught 0 to r dr by h square plus r square to the power 3 by 2. Now integration can be calculated like this. We have to use substitution when we have taken z square equal to h square plus r square. So 2z dz will be 0 plus 2 r dr. Now z dz equal to r dr. So 0 to r dr by h square plus r square to the power 3 by 2, 0 to r z dz by z square into 3 by 2 power. So integration dz by z square, and integration z to the power minus 2 dz, or z to the power minus 2 plus 1 divided by minus 2 plus 1. So in the limit minus 1 by z 0 to r, we get the value of integration. Now putting the value we have under bracket minus 1 by root under h square plus r square, and so taking the limit minus of 1 by under root h square plus r square, because this is variable, this is not variable. So putting the value of r, so r square minus 1 by root h square, or equals to under bracket 1 by under root h square minus under root h square plus r square, or equals to 1 by h minus 1 by under root h square plus r square. So we get finally flux is equal to q into h by 2 epsilon naught into under bracket 1 by h minus 1 by under root h square plus r square, or q by 2 epsilon naught into 1 minus h by under root h square plus r square. So the flux of both cross sectional area will be 2 into phi, so equals to q by epsilon naught under bracket 1 minus h by under root h square plus r square. This is the flux from both circular area. It is total flux from the circular area. Now phi lateral, we can calculate total flux minus flux from both cross section. And now Gauss's law, we know that total flux is q by epsilon, that is charge enclosed by epsilon naught, and minus of 2 phi. So this will give the flux through lateral area. Now another method can be also used. The second method We have to consider a circular strip on lateral surface like this, as we have shown, of thickness dy. So this is r and this is h, and this will be under root y square plus this is if it is this is equal to y. We have taken a circular strip at a distance y from the center. So this will be under root, this length will be under root y square plus r square, and at this point electric field in this direction. And now if this is theta, then it will be 90 minus theta. So electric field and the area vector will be in this direction. So electric field and dA vector, the angle between these two vector is 90 minus theta. Now we can calculate using same method. Phi equal to integration d phi integration e vector dot dA integration e dA cos 90 minus theta integration e dA sin theta. Now integration will be from minus h to plus h. So minus h to plus h, because here we have taken y as a variable. So 1 by 4 pi epsilon naught and q by under root y square plus r square into 2 pi r into dy into r by under root y square plus r square, or 2 pi r square q by 4 pi epsilon naught minus h to h dy by y square plus r square to the 3 by 2. Now integration can be solved with this method. Integration of dy by y square per r square by 3 by 2, or integration of if we take here tan theta is y by r, so sin theta will be p by under root b square y by under root y square plus r square, and if we take y equal to r tan theta, then dy will be r sec square theta d theta. So dy is r sec square theta d theta, and y is r tan theta, so it will be r square tan square theta plus r square to the power 3 by 2. So integration r sec square theta d theta r to the power, taking r square common on both terms, so taking it out from the bracket. So r to the power 2 into 3 by 2 into sec square theta to the power 3 by 2. Now it will be rq, and this r cancel, so only one r will left. So 1 by r square into r square will left. So 1 by r square into sec square theta by sec cube theta. Now sec square theta will cancel sec square, and only 1 by sec theta will left. So 1 by r square into 1 by sec theta d theta, or 1 by r square integration cos theta d theta. Now integration of cos theta is equal to sin theta, and limit will be from minus L to L. Because we have 1 by r equal to under root sin theta is 1 y by under root y square plus r square. So we have to because here y is variable, so limit will be from minus h to plus h. So 1 by r square under bracket h by under root h square plus r square, or minus of h by under root minus of h square plus r square, or 1 by r square into two h by under root h square plus r square. Hence total flux phi will be r square q by 2 epsilon naught into 1 by r square into 2h by under root r square plus h square, or q by epsilon naught h by under root h square plus r square. Here an example is shown. A plus q charge is placed inside the spherical surface, then phi will be integration d phi integration e vector dot. Here if we take a a small elemental area at this point, then the direction of electric field and dA vector will be in the same direction, because d equal to n cap, keep n cap perpendicular to the surface, and also we know that the electric field due to point charge is radially outward, so electric field will be along the direction of radius vector. So we can also write 1 by 4 pi epsilon q by r square into n cap for the direction. So if we take flux of this charge, this electric field, so we have 1 by 4 pi epsilon naught q by r square n cap dot dA into n cap, or 1 by 4 pi epsilon naught q by r square integration dA, and the total area of a sphere is 4 pi r square. So 1 by 4 pi epsilon q by r square into 4 pi into r square equal to q by epsilon. So flux through the spherical surface enclosing a charge plus q at the center will be q by epsilon naught.